All right, sorry about that, folks. I just can't have anybody's name being spoken into this video because I can't publish it online. So, sorry about the shouty bit there at the end. When I start saying that in the future, just ignore me. So, I'm going to get all my numbers and I'm going to divide those by 3. Popping that into my calculator, I'm going to press A over B 0.74 plus 0.69 plus 0.81. I've been a little bit distracted though, so I'm just going to double check this in a second. My answer is not 0.7466, not 0.7466, so I'm going to say that's not 0.747. And in actual fact, I'm going to say not 0.75 because there's not more decimal places there. It gives me in 2 decimal places. I give it in 2 decimal places. When you get a mean and you leave it as that, not 0.747, this is saying that you've got more accuracy than you really have. So if you're doing a mean, if you're doing an average, and you've got 2 decimal places in your data, make sure you give 2 decimal places in your answer. The diagram shows a bullet moving towards a wooden block. The bullet is moving at a velocity of 170 meters per second. The mass of the bullet is equal to 0.03 kilograms. Show that the momentum of the bullet is about 5.0 kilogram meters per second. Yes, we've done this before. No, we're not going to not do it again. We're going to say that momentum is equal to mass times velocity, 0.03 times 170. Momentum is equal to 0.03 times 170, giving me an answer of 5.1 kilogram meters per second. The bullet glides to the wooden block and sticks in it. The bullet and the wooden block move off together. The mass of the wooden block is 0.80 kilograms. So we have got momentum 1 is equal to momentum 2. The momentum before is equal to the momentum afterwards. So this is the momentum, total momentum, momentum 1. So I'll say P1 is equal to 5.1 kilogram meters per second. That is the same as momentum 2, which is the momentum after they've collided. Now, to find the mass total, I need to find the mass of the bullet plus the mass of the block. So B, mass of the bullet is the bullet, mass of the block is mass of L, which is the mass of the bullet, 0.03 kilograms, 0.03 kilograms, plus the mass of the block, which is 0.8 kilograms, meaning that this mass is 0.83 kilograms. Calculate the velocity v. I don't know what that is, but I'm going to be finding out in just a second because momentum is equal to mass times velocity. I'm going to divide across by m. Momentum divided by m is equal to velocity. The momentum is 5.1 divided by the mass, which is 0.83, giving me my velocity of I do not know yet. Now I'm going to divide it in. 5.1 divided by 0.83, giving me my total velocity of 6.1446 meters per second. Two decimal places there. I'll give it back here. 6.14 meters per second is my velocity. It's always nice to see an old friend, isn't it? Andrew skis down a hill. I tell you what, I'm getting jealous of Andrew and his skiing. We had this one already, but it's all right. We'll do it again. His mass is equal to 67 kilograms. Show that his momentum, which we don't know for sure, is around about 2,000 kilogram meters per second, and when his velocity is 31 meters per second. Momentum is equal to mass times velocity. Momentum will equal 67 times 31. Momentum will equal 67 times 31 on my calculator is 2,077 kilogram meters per second squared. It's another momentum question. He falls over when his momentum is 2,000 kilogram meters per second. After he falls over, he slows down by sliding across the snow. It takes 2.3 seconds for his momentum to reduce to 0. Calculate the average force on Andrew as he slows down. Remember, we're going to be using this equation. F is equal to mv minus mu divided by the time taken. I have the time of 2.3 seconds. I have got an initial momentum, so an mv, if you like, of 2,000 kilogram meters per second. I have got an mu of 0 because something that's not moving has got no momentum. And we want to find the average force, and I don't know how many newtons. Force is equal to mv minus mu divided by time taken. Force is equal to 2,000. Take away 0 divided by 2.3. The force will equal 869.565. 869.565 newtons is my answer. And it gave me 1 decimal point, so I'll give it 1 decimal point back. That is the same as 869.6 newtons. A father pushes his child in a cart. The cart starts to move. The child in the cart, doesn't he look a bit like psychotic there? Just a little bit. The child in the cart have a total mass of 50 kilograms. So that's 50 kilograms for that. They travel at a velocity of 4. Actually, do you know what? I will say one thing here, okay? If you've ever got something like this, I just want to let you know, these little sub numbers here, okay? So M total, MB, ML, they're very useful for telling apart the different masses. Let's say that we've got to do something with the father and the cart separately or together or whatever. Just having those little subtext, subscripts is very useful. If you don't understand what I did with that subtext, please come and speak to me so that I can help you out with it, because it will be useful. Calculate the momentum of the child in cart. Momentum is equal to mass times velocity. Momentum is equal to 50 times 4. Momentum is equal to, yes, I'm using my calculator, absolutely, because if I mess up, what's the point of living? With oneself, 200, momentum is equal to 200 kilogram meters per second. Everything is good there. Everything is good there. Happy days. The father applies a steady force for a time of 1.5 seconds. So F is equal to, I do not know how many newtons. The time is equal to 1.5 seconds. The momentum of the child in cart increases by, momentum is equal to, increases by 540 kilogram meters per second. Calculate the force with which the father applies. So we can have F is equal to mv minus mu divided by t. We can also write that as F is equal to delta momentum divided by time. So that's what I'm going to be writing here. The force is the change in momentum divided by the time taken. It's just asking for, it's given me this momentum increase. It's asking me the amount of force. Force is equal to 450 divided by 1.5. And yes, I'm using my calculator because we don't want to mess up. The force is equal to 300 newtons. Write that in there. Happy days. No extra silly stuff, no minutes. It's kilograms, meters per second, newtons. Everything matches up. Everybody's happy. Apart from the child when he gets to the bottom of the hill and realizes the cart has no brakes. A truck is towing a car along a level road at a constant velocity. Both vehicles are traveling at 13 meters per second. The driver of the truck then accelerates at 1.2 meters per second squared until both vehicles are traveling at 20 meters per second. Calculate the time taken for this acceleration. So, I have got an initial velocity of 13 meters per second. The driver of the truck is accelerating. A is equal to 1.2 meters per second squared. Both vehicles are traveling then at a final velocity of 20 meters per second. Calculate the time taken for that to happen in seconds. A is equal to v minus u divided by t. A will be equal to the end velocity 20 minus u, the start velocity, divided by the time taken, which is t. A is 1.2. So I've substituted before I rearrange. I'm going to swap t and a. T will equal 20 take 13 divided by 1.2. T will equal 5.83. Hang on now. Did that wrong, didn't I? No, I didn't. Yep. T is equal to 5.83 seconds. Calculate the mass of the car. M is equal to 1,400 kilograms. Calculate the resultant force on the car. F is equal to, I do not know how many newtons, to produce an acceleration of 1.2 meters per second squared. Init fam wagwan, init mush, blah, blah, etc. I need to find F so it can stay as it is. A is equal to 1.2 times the mass, which is 1,400. 1.2 times 1,400 is equal to 1680 newtons. I don't have to do significant figures or anything, so I can leave that number. Figure 18 shows identical filament lamps connected together to a 12-volt power supply. Calculate the potential difference across each lamp. Right, so this isn't really a maths question, but I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 bulbs. They are connected together in series. So the total voltage in a series circuit is voltage 1 plus voltage 2 plus voltage 3 on and on. We have got 8 lamps here. So the total power supply going in is 12 volts. Divide that by 8 lamps, and that will tell you the amount of voltage in a single lamp. 12 divided by 8 equal to 1.5. Because if I add this voltage plus this voltage plus this voltage plus that plus that plus that plus that plus that, I should equal to 12 volts, and the answer is 1.5. The power output of each lamp is 0.75 watts. Power is equal to 0.75 watts. Calculate the resistance of each lamp. I do not know how many ohms. I've got the potential difference of each lamp, which is 1.5 volts, and it's asking me to find resistance. There's no equation for resistance when I've got power and voltage. However, there is an equation for power, current, and voltage. So I can find resistance if I've got voltage and current. So let's find current first. Now, this is a difficult question. Yes, 4 marks. So you need to do one calculation to find an answer and then use that answer in your second calculation. So power is equal to current times voltage. I'm going to divide across by volts to find my current, and my power is going to be 0.75 over the voltage of 1.5, which will equal a certain amount of current. 0.75 divided by 1.5 will equal 0.5. So of course it will. 0.5 amps is equal to the current. I'm going to add that over to my box of tricks, my collected terms here, and see if that makes it a bit clearer. It's asking to find the resistance. Now I can either use P equals I squared R, or I can use V equals I times R, which is what I'm going to do. V is equal to I times R. I'm going to divide across by I so I can find R as a subject of the equation. The voltage was 1.5, the current was 0.5. That will equal my resistance, and yes, I'm putting it into my calculator. 1.5 divided by 0.5 is equal to 3. 3 ohms is my resistance. Good Lord, make this stop. The airplane is powered by an engine that burns fuel. We've got some vertical forces happening here. I've got 7.5 kilonewtons down and 8.4 kilonewtons up. The fuel supplies a total of 6,500 kilojoules of energy every minute. The efficiency of the engine is 0.70, or 70%. Calculate the power output of the engine. Give your answer in kilowatts. Okay, well, 1 kilowatt is equal to 1,000 joules per second. So let's collect my numbers. So total energy total is equal to 6,500 kilojoules. Efficiency is equal to 0.70. Calculate the power output of the engine. So that will be the useful energy from my engine, and I don't know how many kilojoules. This is 6,500 joules every minute, actually. I've just spotted that. So I'm going to divide that by 60 to get the amount of joules every second. 6,500 divided by 60 is equal to 108.33, 108.33 joules, kilojoules per second, which is the same thing as kilowatts. But anyway, I digress. Efficiency is useful divided by total. I'm going to rearrange that to find my useful, so I multiply across by T. Total energy multiplied by efficiency will equal the power output, the useful power output. ET 108.33 times the efficiency, 0.7, will equal my useful energy. 108.33 times 0.7 is equal to 75.831. 75.831 joules is equal to my useful energy output every second. So I can write that in 75.83 watts. Kilowatts, pardon me. I didn't have to do any changing because it wanted my answer in kilowatts. If it wanted my answer in watts, then I would have to have changed things around. That's English, isn't it? That is. All right. Some students investigate a model of the craters produced by meteorite impacts. They drop balls into a tray filled with sand. They use 6 balls with different masses. Clever idea. They drop each ball from the same height. Excellent. So they've got, a control going on there. That's good. That's a photograph of the sand after several balls have hit. When one ball hits the sand, it has a velocity, v is equal to 6.2 meters per second. It has a momentum of 0.46 kilogram meters per second. Calculate the mass of the ball. I don't know how many kilograms. Momentum is equal to mass times velocity. I want to find my mass, so I'm going to divide across by velocity to say P over V is equal to M. 0.46 divided by the speed, which is velocity, 6.2 meters per second, will equal my mass. Pop that into calculator. 0.46 divided by 6.2 is equal to 0.074. 0.074. And I'm going to leave it at that, just because. The ball takes time of 0.17 seconds to come to rest after it has hit the sand. Calculate the average impact force. It'll take 0.1 seconds to come to rest after it hits. All right, okay, so we've got the initial momentum, and remember that F is equal to mv minus mu divided by t. So mv, final velocity, will equal to 0 kilogram meters per second because it has come to rest after it's hit the sand. Mu will equal the momentum that they've given us in the question, 0.46 kilogram meters per second. The time taken for that is 0.17 seconds, and it's asking me for the force. Oh, I've written down time twice, sorry. In newtons, I'm going to write down my equation. F is equal to mv minus mu divided by t. Put my numbers in. F is equal to the final velocity 0, take away 0.46 divided by the time 0.17. Pop it into my calculator. 0.46 divided by 0.17. My answer is 2.70. Okay, let's have a look at the next one. 2.705 it was. I was debating whether or not to write it all down, but I'm just going to round it down to 2.7. Ah, la 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 la. A car headlamp has a power rating of 55 watts. What? That's very funny. It's not actually. I am just going crazy talking to myself. The current is 4.4 amps. Calculate the resistance of the headlamp, and I don't know how many ohms. There is an equation that links P, I, and R. P is equal to I squared times R. I'm going to divide across by R so that I can have P over I squared times R. I'm going to pop that into my calculator. 55 times 4.4 squared, giving me 1064.8. It's not times that, it will equal that. Sorry, folks. 55 divided by 4.4 will equal my R, and that gives me an answer of 1064.8 ohms. We don't have to do anything about it. We can just leave that as it is, and the reason why we can leave that as it is because what have I done wrong here? Something not right. I pressed the wrong button. That's right. That makes a lot more sense. Common sense tests, always worthwhile doing. 2.84 ohms. Instead of pressing multiply, I accidentally pressed, instead of pressing divide, I accidentally pressed multiply. So, that would have been silly. Common sense test, always useful. Sound travels slower in cold air than it does in warm air. The equation relating the speed of sound in air to the density of the air is speed of sound equals k over root density, where k is a constant. The table in figure 7 gives some data about the speed of sound in air and the density of air. So there's my speed of sound in cold air, density of 1.9. Warm air is that. Excellent stuff. Use the equation and the data in figure 7 to calculate the speed of sound in warm air. Give your answer to an appropriate number of significant figures. Very clever. All right, so what we have to do here is first off figure out what this k constant is, because it's given me the density. It hasn't given me k, so I can't find speed of sound. So the first thing I've got to do is find k. Now, when I find k, to find k, I will need to use the data that I have available on this in this table already, and I've just frozen. Okay, the data I have available already in this table. So I've got the speed of sound is equal to 331 meters per second in cold air. So I'm doing cold air first, and the density is equal to 1.29 kilograms per meters cubed. It's telling me that my equation, speed of sound, is equal to k over square root of density. So what I'm going to do is I'm going to multiply across by root density. Speed of sound multiplied by root density is equal to k. Speed of sound 331 multiplied by the square root of 1.29 will equal k, my spring constant. 331 multiplied by square root of 1.29 will give me my constant, which is 375.94. Okay. 375.94 is equal to k. 175.94 is equal to k. I'm going to bring that. I'm going to leave it as it is just for now. I'm going to leave it as it is just for now, but I'm going to give it to the appropriate number of significant figures in just a minute. Bum 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 bum. Yes. Yeah. Okay. In my warm air, then I'm going to be able to find the speed of sound because I have 375.94 as k. So I do not know my speed of sound in meters per second. My density is in warm air 1.16, and k is equal to 375.94. I'm going to write down my equation. Speed of sound is equal to k over square root of density. I'm going to write down that s is equal to 375.94 divided by the square root of 1.16. Pop this into my calculator. I'm going to write down 375.94 a over b square root 1.16, giving me an answer of, oh, that even had to blink for a little second, 349. So I'm going to write s is equal to, oh, I don't want to do it here. I'm just going to write here, s is equal to 349.051. Now, what's an appropriate number of significant figures? Well, just give me that. I'm going to say three significant figures, okay? Because 0.51 of speed, not very important. Write down my answer, 349. An LED lamp has a power rating of 3 watts. Power is equal to 3 watts. The voltage across the lamp is 12 volts. Calculate the current in the lamp in I don't know how many amps. Power is equal to current times voltage. Divide across by V. P over V is equal to I. 3 divided by 12 is equal to I. And yes, I am going to do this in my calculator, even though we know it is a quarter. 0.25 is the current. Please, God, let this stop. Oh, and it's frozen. Oh, and it's disappeared. Oh, hold on. Oh, it's the end. Oh, it's the end of all the questions. All right, there we go. Thank you for sticking with us for so long, folks. I'm sorry that I made so many mistakes. Any of those questions you don't particularly understand, get in contact with me. But I'm going to stop talking at this computer now because, quite frankly, it's a lot of time by oneself. Okay, see you later. Any questions, drop them in the comments or pop them in an email. Bye. Bye.